Hello everyone. Today we're going to continue lesson 15.2 and day 2, and that is on graphing logarithm functions, continuing to take a look at other examples dealing with logarithm function, including real-world situations. First problem says write each transformed function, use g of x for each transformed function, and so we're going to actually just write the function as it is transformed from the original logarithm function. So first one says that the function natural log of x is reflected across the x-axis. So we're going to call the new function g of x. And as you know, reflection across the x-axis causes a negative in front of the function. So it becomes negative natural log of x. And that's all it is. Part B says the log base of 8 of x is vertically compressed by a factor of 0.5. So we know that g of x is going to be 0.5. Vertically compressed means it's just multiplying in the front, log base 8 of x. And next, it says log base 3 of x is stretched by a factor of 4. So it's going to be g of x equals vertically stretched, that means multiplying by 4, log base 3 of x. And finally, part D, the log of x function is shifted 3 units left and reflected across the x-axis. So we got two things going. G of x is going to be across the x-axis, that means negative, and then log of 3 units to the left, that means x plus 3. And that is the answer for that problem. And let's take a look at the next slide. You can obtain a logarithm model for real-world data either by performing logarithm regression on the data by finding the inverse or by finding the inverse. So either you can use 1, the logarithm regression, and this is done on a graphing calculator. So that's 1. 2 is actually calculating the inverse, and this method we will just call it the by hand method. So we're actually going to do both of them to show you the difference between the two. So here we have a real world situation. Maria made a deposit in a bank account and left the money untouched for several years. The table lists her account balance at the end of each year. So again, we're going to do this by both the by hand and then the graphing calculator method. So let's do the by hand method first. So we know that when x equals to 0, that equals to the initial amount. So therefore a, we know, is equal to 1,000. And so giving the equation, remember, y is equal to ab to the x as the general formula for the exponential function. And so we're going to write an exponential function. So here, part A says write an exponential model for the account balance. And we're going to need to find, so we have A already, and we need to find B. And remember, to find B, we're just going to take R2 divided by R1. So that ratio is actually 1020 divided by 1000 is actually equal to 1.02. And if we do the same thing here, it's actually going to give us the same thing. So it's pretty close to 1.02 consistently. So therefore, we know that y, the function, is equal to initial value of 1000 times b, which is 1.02 to the x. And this is the function. So let's use t for the variable because it says function of time. So we got, and then also let's go ahead and use b to kind of put it in reality here. We have b, that stands for the balance, but really it doesn't matter if you use x, y, or bt. So in this case, we'll just say b for balance, t for time. And that is the answer for part A. Part B says find the inverse of the exponential model after rewriting it with a base of e. So here we have the equation from top, and it basically says to write the equation using the exponent and the base of e. And so the only thing that we need to do is rewrite this base right here as e to the x. So let's say we do not know what e raised to the something power, so we'll call it e to the c, is going to equal to 1.02. Since we do not know what value gives us that, we're going to set up an equation to solve for it. So we're going to rewrite it something like this. B for the balance equals 1000 times e to the c and then to the t power. So again, we do not know what e raised to the power is going to give us 1.02. So we have a new equation, e to the c equals 1.02. So that's our new equation based on just looking to rewrite the 1.02 as e to the something. So again, I want to be able to write e to the something that is going to give us 1.02. So you can use a calculator and just keep guessing, but then we want to know how to get it right away, and not having to sit here and just guess all day and let e to the raised to something power. So we're going to apply the logarithm function to solve for this. So we know that the inverse of e is actually the natural log. So if we natural log both sides, we're going to have natural log of e cancel out, which just give us c is equal to the natural log of 1.02, and that is approximately 0.02. So if we actually write this, evaluate this back into the c right here in the original problem, we would have b is equal to 1000 times e to the 0.02 t. And that is going to be our equation, basically by rewriting the base as a function of e. And so answer for part B is right here. And that is actually one part of the answer. So we're actually going to need to find, so that part is the first part, which says find the model after rewriting it with the base of e. So that's the first part. There's two parts to this question. Second, and it says, so writing it with the base of e is first. Two is finding the inverse of that. And I am going to have to rewrite that problem over here. So I don't have enough space. B is equal to 1000 e to the 0.02 t. Now we call that we need to find the inverse for the function by hand. So to find the inverse, remember in a real world situation right here, you can obtain by the function by solving for the other variable, which means this is b as a function of t. So we're going to actually solve for t. Once we have t equals something, that's going to be our inverse. So we're going to need to find t. So what we're going to do is, first step is to get rid of that 1000 because we want to isolate t. So we're going to start by taking out of the 1000 out of the other side. So we have b over 1000 equals e to the 0.02 t. Next, again, we're going to apply the natural log, the inverse of e, to both sides. So we'll have natural log cancel out e. You have 0.02 t is equal to natural log of b over 1000. The next thing we're going to do is actually get rid of that 0.02. So here's another way to rewrite that. Well, 0.02 is 2 out of 100. If you know the fraction, that's 2 out of 100, which means 1 out of 50. So we have 1 over 50 t on the other side. So to get rid of that 1 over 50, we're going to multiply both sides by 50. And so that is actually what t equals to. So we have t equals to this function right here. And that is going to be the inverse. So t equals 50 natural log b over 1000. And so this is what we call the inverse by hand. And that is going to be our answer for part B. So now going back to the question for part C says perform the logarithm regression on the data using the account balance as independent. And so because in the sense we are looking for the inverse, and this table that we have right here describing the relationship between the account, we're going to switch the normally this would be the x value, this would be the y, or in the graphing calculator we'll call it L1, this is L2. But because we're trying to find the inverse, we're actually going to switch this. The L1 is going to be the x value. So this is going to be the x, this is going to be the y. So that is the reason why when we enter it into the graphing calculator, we are going to call the left side the account balance, the x values, and then the year is going to be the y values. So there it is. I've already gone ahead and accumulated, drawn the two functions on the graphing calculator using the decimals. And so let's go ahead and point out the equation for the, after you enter the table, so you can go ahead and try this on your own. Make sure you do try it at this time. Go log into decimals and start a table and enter the table as I have shown here. And again, the logarithm regression function is y1 approximate a plus b natural log of x1. So that's going to be the function. And notice that the original points are actually graphed. It should be graphed over here somewhere. It's cut off from the graph. And then this is the equation that we have done calculated by hand from earlier. So I've got this one is the calculator generated computer decimals. And then this is the red one is the one that's by hand. So if you actually have them all in the same graph, I just wanted to show you one is black and one is red, and they are exactly the same graph of from each other. So this shows you that whether you do the calculator method, calculated by generating the regression on the calculator, or doing it by hand, you will get the same answer. So that is the example from today based on the real world situation. So hopefully that helps. And you may now proceed with your assignment, the book set, and then finish your 15.2 and then go ahead and copy notes for 16.1 and have a good day.